In this example, I've created a class called Square. The Square class defines two private data members, length and width. If I want to set side values for the square, the length and width of the square, I'm going to have to find some way of passing the data in so that these private values can be set. Well, I've decided to accomplish that using a constructor. I've got two constructors that I've created here, so the constructor is overloaded. The first constructor, entitled Square, is a public constructor, which means that from outside this class, wherever this is publicly available, I can instantiate this class simply by passing parameters into the instantiation statement. I'm passing in two parameters, double L and double W. Now, the length variable here is going to be assigned to the parameter L, while the width variable will be assigned to the parameter W. The other constructor I've defined simply has a single parameter, a double called S, which I'm using as a side. Since the side measure of a perfect square is equal for all four sides, then I'm setting length equal to width equal to the parameter S. I've also defined a method of my class called area, and the area method returns the length times the width, so that way I can get the area of my square. Now, to call the constructor, I simply use the standard instantiation statement here in my main method. Square S equals new square. Now remember that when we've used this instantiation process previously, after the name of the type that we want to create or class we wish to instantiate, we have an open and closed paren. The assumption there is that we're calling a zero parameter constructor. In this case, however, we do have parameters that we need to pass into the constructor. So technically, as we revisit this instantiation statement, square that's being used here defines the type of object we're creating, and this reference to square is basically a call to its constructor. So I'm passing in 5 as the value of the width and the length of this particular square. Then I'm simply going to call the area method to write out to the console the area of that square, which should be 25. Let's execute that and see what we get as a result. According to our resulting window, 25 is the return value of the area of the square. So that means that the values have been passed in successfully. Let's go back and make a little change. What if I change one of the arguments from 5 to 10? That should change the area because that will change the width of the square. Let's execute this again. And as you see, we do have the appropriate change reflected in our output. Now, what if I only passed in one value instead of two? Let's take out the comma 10. We're passing in simply the value of 5 as a parameter. That means that I should be calling the second constructor instead of the first. So the length and the width will both be set to 5. Therefore, the area, once again, will be 25. Upon execution, we get exactly the result that we would expect. So as you can see, the constructors are useful for providing ways to pass values into that class upon instantiation of the class. I could also use the constructors to set other values, parameters, setup, initialization, etc. as I wish. In these cases, I have public constructors. Be aware that you can limit the accessibility to the instantiation of this object by limiting the accessibility of the constructor as well. Using private, internal, etc. would limit the availability or accessibility of the constructor and thus limit the scope from which you could actually instantiate the class.